All right, let me get my little thing here. Here we go. All right. Claim, evidence, reasoning. That's what we're focusing on this week with Newton's second law. So here we go. Before we get started, we're going to be talking about what CER is, what a claim is, what evidence is, what reasoning is, how we use CER with some real life applications and Newton's second law, and then it'll be your turn. We are talking about writing today, so as I'm going through this presentation, you should be taking some mental notes because you are going to be responsible for writing at the end of this presentation. So here we go. What is CER? CER stands for claim, and then evidence and reasoning. It's how we write in science class, and in fact, it's how you write in most of your classes. In fact, at George, we like to use the CER model in most of your classes. But this is the way 100% to write in a science class, so let's get it going. Step one, what does C stand for? It stands for claim. Claim is just simply a statement of the answer to the question. So I'm going to give you a question, and then you're going to give me an answer. That's going to be your claim. But we have to go a step further and provide some evidence after we answer the question. This could be an observation, something that you saw. It could be data. It could be numbers that you have. Or it could be research that you did via Google, etc. After we have some evidence, we need to back it up with our reasoning. Why did you include that evidence? In this class, it's mostly always going to be a scientific principle. In this case, this week, it's Newton's second law, and it's going to help support why you put your evidence in here to support your claim. So, this is called claim, evidence, reasoning, or CER. Answer the question, provide some numbers or data as backup, and then why did you include that numbers, and how does that support the scientific idea that we're talking about during that week? So let's move on. Using the evidence provided, make a claim about the relationship between mass, force, and acceleration based off of Newton's second law. All right, well, let's just look at the data first before we get started. Looks like we got soccer balls and they're all about the same size. No, they're not. Looks like this one's smaller and this one's a little bigger and this one's a little bigger. And it looks like they're all traveling about the same speed or acceleration. Okay, and it looks like this guy is some kind of goalkeeper because he's got some gloves on and his job is to stop him. So let's dive into the data. We have mass 1, mass 2, mass 3, which probably explains why the soccer balls are bigger. This is probably mass 1, mass 2, and mass 3. Acceleration, 10, 10, and 10, which shows why right here they're all about traveling at the same speed or acceleration. And then force. Looks like our force is increasing, 10, 20, and 30. Okay, so there's more force based off when there's more mass. And in fact, we have a graph right here, graph 1, that shows as the mass is increasing, so is the force. It's also increasing. If we remember from last week when we have this pattern that on a graph of an upward slope, that is a direct relationship. So let's go ahead and write our first claim. According to table 1, there's a direct relationship. There it is, direct relationship between mass and force, while the acceleration remains constant. If you note, acceleration is not on this graph because we're really just looking at mass and force, and it's because acceleration isn't changing. It's the same. So there we go. That's our claim. Let's move on to some data to back up that claim. When the mass was 1 kilogram, there it is, the force was 10 newtons, and the acceleration was 10 meters per second per second. All right, so I just described this part of the table right here, or even this part of the graph. All right, let's do it one more time because we need 2 pieces of evidence. So when the mass was 3 kilograms, the force was 30 newtons, and the acceleration was 10 meters per second. So we answered the question, and then we backed it up with 2 pieces of data or evidence. Let's finish the last part. Reasoning. Newton's second law I said that because it's right here in the question. Newton's second law states that force equals mass times acceleration. So as the mass increases, the force increases if acceleration remains constant. There we go. That was the first one. So let's try that again, but a little faster. Using the evidence provided, make a claim about the relationship between mass, force, and acceleration based on Newton's second law. So let's look at this. The soccer balls all look to be the same size. Except it looks like our acceleration is faster, and even faster. So, according to Table 2, I got that from up here, there is a direct relationship, upward slope, so direct relationship, between acceleration and force, while mass remains constant. There's our mass staying the same. So we answered the question, but we need some evidence to back that up. So evidence, we need two pieces of evidence. So let's just grab, say right here, and why not the one directly below it. So let's just describe this set of data, and then we'll explain this set of data. So when the acceleration was 10 meters per second, units matter, the force was 10 newtons when the mass was 1 kilogram. So I've described this data set. Let's pick one more. How about the one right below it? When the acceleration was 20 meters per second, the force was 20 newtons, and the mass was 1 kilogram. So I've explained two pieces of data, here and here. All right, but why did I include that? That's the next part, reasoning. Newton's second law states force equals mass times acceleration. So as the acceleration increases, 10, 20, 30, or 10, 20, 30, the force increases. Force, 10, 20, 30, 10, 20, 30. The force increases if the mass remains constant. Mass is right here. We don't, again, see it on the graph because it's not really doing anything. So we would not include that on the graph. All right, let's try one more. Again, we need to answer the question. We need two data points, and then we need to say why we included those two data points. So let's do it. Using evidence provided, make a claim about the relationship between mass, force, and acceleration based on Newton's second law. Claim. All right, before we do that, let's look at the data. We have our mass. It looks like our mass is going 2, 4, 6. It's increasing, and we can see that on the graph, 2, 4, 6. While the acceleration, 5, 2.5, 1.7, they're going down. This is the opposite of what we've seen before. Remember, when it goes up, it's a direct relationship, but when it's going down, it's decreasing. We call that an inverse relationship. So looks like we have an inverse relationship between mass and acceleration, while force is the same. And if we look at our example here, looks like the ball size is increasing. It's getting bigger and more mass. And it looks like the acceleration is inverse to that. As the ball gets bigger, looks like the acceleration is going down. All right. So according to Table 3, there's an inverse relationship between mass and acceleration, while the force remains constant. Let's back it up with some data. Again, I need two pieces of data. So let's pick maybe right here. Let's explain this data set of Table 3, and then maybe this data set right here. So when the mass was 2 kilograms, the acceleration was 5 meters per second, and the force was 10 newtons. When the mass was 6 kilograms, the acceleration was 1.7 meters per second, and the force was 10 newtons. I've explained two pieces of data directly off my table. Now, why did I include that data is our next part, reasoning. It kind of sums up the rest of this because I have yet to talk about Newton's second law. So Newton's second law states that force equals mass times acceleration. So as the mass increases, 2, 4, 6. The acceleration decreases. Acceleration is going down. 5, like 2.5, and I think like 1.7. So as the mass increases, the acceleration is decreasing if the force remains constant. All right, your turn this time. So using the evidence provided, make a claim about the relationship between mass, force, and acceleration based on Newton's second law. So I'm going to help you out just a little bit here. You are responsible for doing this on a test later this week, so I'm really trying to give you answers here. So according to table, there is a blank relationship. It's going down, so it's either direct or inverse. Either one of those two, 50-50 shot there, between probably that and probably that, while something remains constant. All right, make sure you fill in those. All right, let's roll on. Evidence. When the blank, and the blank. Well, there's not much going on here, so let me help you out a little bit. When the, let's talk about mass. Let's pick, in fact, two pieces of data here. Let's explain maybe this section and maybe this section. So when the mass was something, don't forget the unit, the, well, we talked about mass, let's talk about this one. The was what? Don't forget the unit. And the, probably this thing that's not on the graph, was what? So we finished explaining this one with that right there. And what about this one? When the something was this, then the, probably that, what's this number, don't forget the unit, and the was what and what. All right, should pretty much just given that to you there. All right, last one, reasoning. Blank states force equals mass times acceleration. I'll give you a hint. It's not his first law, and it's not his third law, and it might be in the question. So as the, what did the mass do? 1, 2, 3. And the acceleration, what's the acceleration doing? 10, 5, 3.3. Is it increasing or decreasing? If the something is remaining constant the whole time. All right. That should be about everything you need. This was claim, evidence, reasoning. We're going to do this all year long. It's pretty hard at the beginning, but it's going to become automatic. And honestly, you should be doing this in every single one of your classes. Answer the question, back it up with some evidence, and say why you included that evidence to back up your claim. All right, best of luck.